Hello students, good morning to all of you. Students, in class 11 physics, our today's lecture is on topic law of conservation of mechanical energy in unit 4. To find the law of conservation of energy, mechanical energy, by the example like an object initially at O is displaced by a certain height, let's say h, till point A, and placed over this height. Okay. Then after, when it releases from point A under the effect of gravity, then we observe that its motion or its speed increased as it comes towards gravity, because it is attracted with a constant acceleration due to gravity g. So let's here in between a point B at x meter distance from point A, when the object is reached at B, let its velocity gain is v1. Okay, and when it just hit the ground, okay, just hit the ground, its velocity is v. Let this is its final velocity before hitting the ground. Okay, then because the object initially at O, therefore it has at rest, and due to rest it has the locational energy, and we discussed earlier the locational energy is called the potential energy. Okay, now when it falls freely under the effect of gravity, its potential energy converted into its kinetic energy when it reaches or just tends to reach the ground is in the kinetic energy. Okay, and in between the path at B, it has both energy, one the potential energy till B convert in the kinetic energy with a velocity v1, and rest part is due to the location at B, h minus x is potential energy. Okay, so here we calculate the three types of energy at three different locations, like energy at A1, let's say E1, energy at B is E2, and energy at O is E3. Okay, for proving this law of conservation of energy, if we calculate the value of E1 equal to E2 equal to E3, then we conclude by the relation E1 equal to E2 equal to E3 that the mechanical energy of a body falling freely under the effect of gravity is conserved. Okay, now we will start. Consider an object of mass m kept at point A above the ground h height. Okay, when it release when it release or we say fall freely under the effect of gravity, it gains its speed increased increased due to constant acceleration due to gravity. Okay, now from figure okay, one thing here also, at A it has potential energy which converts in kinetic energy as object reaches the ground. Okay, now from figure energy at position A. Okay, now here students, if the object is kept here, then it has velocity or we say initial velocity u is equal to 0. Okay, and final velocity is also 0 because it is not yet started. So it has height here which is equal to h, therefore at A velocity 0, height is h, therefore potential energy is equal to mgh and kinetic energy is 0, therefore total energy or we say mechanical energy is equal to the sum of potential energy and kinetic energy you get from here, that is mgh plus 0, therefore energy at A is mgh, this is E1. Okay, now at B, okay, when the object is falls under the effect of gravity, when object falls from A and reaches to B, it gets velocity v1 and height from the ground from ground is h minus x. Okay, therefore it has potential energy which is equal to mg h minus x and kinetic energy half mv1 square. Okay, now from second equation, third equation of motion, v square minus u square equal to 2g s. S is equal to the distance traveled from A to B is x. Here. Okay, now as the initial velocity is 0, then we get this is equal to v square. Okay, now we can calculate v square by 2 is equal to gx. Okay, now this is equation first. From first, here the kinetic energy is equal to half mv1 square. Okay, then m v1 square by 2. In place of v1 square by 2, we can put the value of gx. Therefore, kinetic energy at this location is mgx. Clear? Therefore, total energy is equal to potential energy plus kinetic energy is equal to mg h minus x and plus mgx. Okay, now when we multiply mg inside the bracket, we get mgh and minus mgx and plus we have mgx. So this mgx cancel with this x, or when we multiply mg inside the bracket, therefore the total energy is equal to at B is mgh. Therefore energy at B, which is equal to E2, is mgh. This is the second locational energy. And third, okay, energy at C, energy at O. Okay, at O, the object is reached at ground, and before hits the ground it has the final velocity. Therefore, before hitting the ground, energy of object, potential energy is 0 because h is 0 near to O, and kinetic energy is half mv square. Here we calculate mv square by 2. Now again, by third equation of motion, we have v square minus u square is equal to 2gx. Okay, 2gs, and we have s is equal to h, therefore 2gh. Okay, and initial energy is 0, therefore v square by 2 is equal to gh. Okay, therefore the kinetic energy is equal to mgh. Now total energy is potential energy plus kinetic energy, which is equal to energy at location third is E3, 0 plus mgh. Here we calculate that E3 is equal to mgh. Hence energy at A, E1 is equal to mgh, energy at B, E2 is equal to mgh, and energy at E is mgh. Therefore E1 equal to E2 equal to E3, that is the mechanical energy at all the three locations is equal to mgh. Hence the mechanical energy is conserved. Okay, note this, and this is the very most important topic when you are calculating the numerical on the basis of the concept of the conservation law of energy. This concept gives you idea to solve the numerical. Okay, next we have mass energy equivalence relation. Okay, this relation is given by the famous scientist Albert Einstein according to his classical theory of relativistic. He explained the universe in the two quantity, one is mass and another is energy, and about according to him about universe, the universe is made up of only the one single thing, and which can be uh, leads in two form or categorized in two form. One is mass and second is energy. He given his relativistic theory, and in this theory he explains that the mass can be converted into energy and energy can be converted into mass. According to him, if we have 1 kg of mass, 1 kg and 1 joule energy, so according to him, or we say 10 kg of mass and 10 joule energy. Okay, so according to him, if 1 kg of mass is converted into energy by using any process, that 1 kg of mass is taken out and it will be converted into energy, then this mass is converted into energy by 1 joule, and then the total energy of universe become 11 joule. Then according to him, if the mass and energy is equivalent to each other, then initially we have 20 joule energy or 20 kg of mass, and after the condition or after the applying the process, we have again the sum is equal to 20. Initially we have 10 kg mass and 10 joule energy, the sum is 20, and after the process applying on the 1 kg mass taken out from the initial mass, then the 9 kg mass we have left and the energy become 11 joule. And we observe here the change in mass and change in energy is equal to again 20 joule. Hence he explained that the change in mass, okay, here in the two process we have the change in mass, let's say del m is equal to 10 minus, or we say 10 m, and here is 9 m, and here is m. We are not using in place of units, we use the symbol of the quantity. Okay, then according to him, the change in mass, that is 10m minus 9m, is equal to small m. Okay, according to him, if we multiply the mass or change in mass with the square of speed of light, then we get the result of energy. That is, energy is equal to product of difference in mass in before process and after process into square of the speed of light in vacuum. Then we calculate how much energy is released by the particle. According to this, we can calculate the mass of 1 kg of particle, like let's say m we have 1 kg and energy of light, speed of light c is equal to 3 into 10 to the power minus 10 to the power 8 meter per second. Therefore you can calculate the energy released by 1 kg of mass is equal to 1 in del mc square, that is 1 into 3 into 10 to the power 8 meter per second, is kg is equal to 9 into 10 to the power 16 joule. This is the amount of energy released by 1 kg of mass, because it is here we are using the mass of the electron. So charge on electron, we can also calculate this energy in the bigger unit or mass electron volt, that is MeV. For calculating this into MeV, we can use here charge of electron. Here electron is 1.6 into 10 to the power 9 minus 19. Okay, so it will be calculated as E is equal to 9 upon 1.6 into 10 to the power minus 19, and here we have 10 to the power 16. Okay, then we calculate here this is equal to 1950, and we have 10.6. Approximately 10 to the power 10 to the power, this is 35 electron joule. Okay, now this will be multiplied with 1 AMU. 1 AMU, this is equal to 1.67 into 10 to the power minus 27. Okay, then you will calculate it. This energy is equal to 5.6 into 10 to the power 35 into 1.67 into 10 to the power minus 27, and now the result will become MeV, which means mega electron volt, or in electron volt unit. This result is about 931 mega electron volt. This is the amount of energy released by 1 kilogram of mass. Okay. Hence, according to this relation, energy is the product of, according to the relativistic theory, energy is the product of mass and square of speed of light in vacuum. Okay, from this relation we can also calculate that del m is equal to energy upon speed of light. Okay, here according to the relativistic theory, the value of mass is equal to initial mass upon 1 minus v square upon c square. Okay, and because of that, the mass of a body is constant till the speed of light in order of 1 million. Okay, because the result v square upon c square is very small if it is less than, if the velocity of the object less than 1 million, then this fraction is too small and we neglect that factor and we get the result. If v square is very smaller than c square, therefore v square upon c square is negligible. Therefore mass of object is equal to its initial mass. Okay, and according to the quantum physics, the mass and energy are not conserved separately but are conserved as a single entity called mass energy. That is, energy is the E is the energy that the object possessed even when it is at rest simply because of its mass, that is its locational energy, and which is called the potential energy of object at rest due to its position or its configuration or its size. So students, in today's class we are learn till the topic the mass energy relation. In the next class we will be going to learn about collision and the concept of collision in one dimension and two dimension. Thank you.